Hello and welcome back to another LeetCode video. We're looking at LeetCode 3238. Find the number of winning players. It's an easy problem, and that means it's perfect to practice interview. Well, to practice interviews, because easy problems don't get into the way, and so they allow you to focus on the interview process and go through the motions as you would in an actual coding interview, where we focus mostly on communications, problem solving, and all of those good things that we're going to be evaluated on. And writing the most efficient solution is almost secondary in those interviews. Really more about being able to have a systematic approach and being able to explain what you're doing. Cool. Step one of the systematic approach is to understand what the problem is. All right, so we are given this integer n representing the number of players in a game and a 2D array pick, where pick at position I is another array that consists of an x and a y coordinate, representing a player x that picked, not coordinate, but representing a player x that picked a ball of color y. Player I wins the game if they picked strictly more than I balls of the same color. In other words, player 0 wins if they pick any ball. Player 1 wins if they pick at least 2 balls of the same color. Player I wins if they pick at least I plus 1 balls of the same color. Return the number of players who win the game. Note, multiple players can win the game. Interesting. So let's look at the constraints. Obviously, we want to know how many, what is this n here, by the way? I don't think they explain it. Oh, no, they do. So n is the number of players. Pick is going to be, which player picks what type of ball. And, what is the limit on n? So we can see n is at least 2. And the length of the picks is, it can be smaller than the number of players. Interesting. So we need to keep that in mind. And that is interesting. Okay, cool. So we have more players than we can have picks. Right. So let's look at an example next. So here we have an example where player 0 picks ball 0, player 1 picks ball 0, player 1 picks ball 0. So I guess player 1 can pick any ball, player 0 can pick any ball to win, right? That's what they said in the beginning. Then player 1 wins if they pick any ball twice, and that's what they do. And here player 2 picks 1 ball twice and 1 ball 3 times. So player 2 doesn't win. So the output is 2, because only 2 players win the game. Okay, let's have a look at the next example. Here we have player 0 doesn't do anything, so it's not going to win. Player 1 picks 3 different balls, so it's also not winning, because they need to win at least one. Well, player 1 picks all kinds of different balls, so never 2 of the same kind. Therefore, player doesn't win. Why do they win when they pick balls? That sounded weird. Anyway. So next example. So here we have player 1 picks color 1. Player 2 picks color 4, 4, 4. So 2 picks 3 times color 4, which is 3. So that's a winner. Okay. So do we know anything about the order of the things that we will receive? You're given an integer representing the number of players in the game, where pick I represents that player I picks the ball of the color. Okay. The player xi. So I guess the order is not guaranteed. So we have to assume that they're just not going to be ordered. But that doesn't matter. I think what we can do is we can do a linear pass through the entire array of picks. And I'm just going to rename it to picks here. And then we just keep track of all the different colors that a player picked. So I guess what we'll have is we will have maybe we could initialize an array, and that array contains a hash map of every entry that tells us how many times it picked a certain color of ball. So that's what we have to do first, and then we just have to iterate over that data structure that we created to identify which players pick a ball more times than what their player number is. And yeah, so that'll be O of n time, O of n space. And yeah, and in the interview, I would ask if that's a good approach, and then tell me, yes, perfect approach, let's go for that. Time and space, right? So first pass is for, well, player, color, in, pix. And I said we would use an array, so we will have a little array. So how should we call this? Scoreboard, maybe? I don't know what we should call that. Let's just call that. And we will initialize that with empty dictionaries. And I'm going to use default dictionaries for every player from 0 to n exclusive. Right, so now we just need to update the scoreboard, I guess. So the scoreboard for a player at player, and then now we're going to access the default dict, and we're going to say color was equal 1. That's what we will do. That's all we need to do to build our little data structure. And now the second pass is over the scoreboard for player in range n. And what we'll do now is we will check, if the maximum of all the values in those dictionaries is larger than player, that means we got a winner. So if scoreboard for player dot values, so the values are now the counts that we've here. If that is larger than player, we get a winner. And to keep track of how many winners we have, you have to have a result, a variable initialized with 0 in the beginning, and that needs to be returned after the whole thing. We could use max here, or we could use any of those is larger than 0, but we have to loop over the array then as well. So we'll just do max, it's simpler. Larger than player, then result 1. So let me just check one more time. Yeah, if 0 has 1 pick, that means number of picks is larger than 1. Yeah, so this larger is, I think, good. So let's just run it through the test cases here. Make sure we didn't make any grave syntax or logic error. Oh no, max arc is an empty sequence. Okay. So, well, how should we call this? Should call the score. Scorecard is players. Empty sequence. And then we do if scorecard. I don't know if there's anything in the thing. And scorecard values larger than player, then we add a result. So, okay. I can't call max on something that is an empty sequence, I suppose. So to make sure that's not an empty sequence, we just check it's not empty. So I hope that fixes that. And it does. Cool. So it passes the test cases. Let's submit it. See whether it passes the final tests here. And it does. Right. So there we go.